In this video, we will learn the mechanism of nucleophilic addition reaction. And before we go ahead, let's again see that the reaction mechanisms are of two types, electrophilic and nucleophilic. And each of these reaction mechanism are again of two types, addition and substitution. Same way, addition and substitution reaction for nucleophilic also. At A levels, the only nucleophilic addition reaction which we are going to study is the reaction of a carbonyl group, that is a compound carrying C double bond O group. And as it is a nucleophilic addition reaction, so nucleophile, which is a donor of pair of electron, is going to be negatively charged and it reacts with a carbon which is carrying a positive charge. So here the carbonyl group is the part of the molecule which undergoes the addition reaction by nucleophile. The two types of carbonyl groups which undergoes this reaction are aldehydes and ketones. Aldehydes and ketones are the compounds which undergo nucleophilic addition reaction. Here we have taken an example of aldehyde. As we can see that the carbon carrying the O is bonded to hydrogen and a carbon group. So as a hydrogen is bonded here, it's an aldehyde, but the same reaction will happen and the same mechanism steps will occur even if it's a ketone. So if the carbon is bonded to both of the carbon group, still the reaction mechanism steps remains the same. This reaction occurs when the aldehyde reacts with another reagent which is HCN. Now as we know that the nitrile group is partial negative, it's an electron negative group and hydrogen carries a partial positive charge. So HCN molecule is going to break heterolytically where CN will carry the bonding pair of electrons which is used with the hydrogen, and so CN will carry the negative charge and hydrogen will carry the positive charge. So let's start with the mechanism step. Here the aldehyde, the carbon carrying the carbonyl group carries a partial positive charge and the oxygen carries the partial negative charge, and the double bond which is present between the C double bond O, one of the bond of this will be broken and the bonding pair of electron which is forming one of the bond will be carried by the oxygen, and hence one of the bond breaks out of the double bonds. In the next step, the CN, which is carrying a negative charge and which is obtained by heterolytic fission of the HCN molecule, is going to approach the partial positive carbon, forming an intermediate carrying a carbon with oxygen and CN group both. The intermediate carries a negatively charged oxygen because as we have seen that one of the bond breaks here and the bonding electron pair is attracted by the oxygen. Next, from the HCN molecule, the hydrogen which is still present and carries a positive charge will be attracted towards the oxygen which is negatively charged, and so an OH bond will be formed in the next step. So the final product carries a hydroxyl group and a nitrile group. Now we can note down that earlier, which is a carbonyl group where C double bond O was present, now has changed to single bonds and a hydroxyl group is added and an CN group is added. So it's an addition reaction where no atom is removed but only the groups or atoms are added, and it's a nucleophilic addition reaction because the first step carries the nucleophile which attacks the carbon which is positively charged. So the final product is a hydroxynitrile product, and we should also note down one more point that if this reaction is happening with the aldehyde, then the carbon which is having the hydroxyl group and the nitrile group is a chiral center. It is optically active carbon because here we can note down that the carbon is bonded to all the four different groups. So such a carbon is optically active and it has got a chiral center. Suppose if the same reaction happens with a ketone, so here will be a carbon group. Suppose if both the groups are methyl group, then only the carbon won't be a chiral center, it won't be optically active. But if one of the group is different, suppose if it is ethyl group, even in ketone, then the carbon will be optically active. And we should also note down that we have seen each and every step with the partial charges, curly arrows, full charges wherever required. So whenever we are drawing such mechanism at an exam level, all the partial charges, full charges, curly arrows should be drawn without fail. And also it should be taken care that the arrows should be pointing from negative towards the positive charge. And if all these points are taken care, then we get full score in such a mechanism question. So I hope the nucleophilic addition mechanism is very clear.